In this lesson, we'll talk about domains as well as compositions of functions. Let's start with domain. The natural domain of a function is every x value for which the function is defined. Let's describe this in example 1 with these three functions. Starting with f of x, the function is 4x plus 1. What is the domain of this function? That is all the numbers that you are allowed to put in place of x. If you think about it, you can put any number you want in place of x, multiply by 4, and then add 1, and nothing ever goes wrong. There's no real work to show, but I'll use D for domain, and the domain is all real numbers. Everything works, so you can use interval notation or just simply write all real numbers. You can put 5 here, multiply by 4, and add 1, no problem. You can do decimals, negative numbers, everything works. Let's try the same idea here, but with the function g of x. It's a more complicated function. G of x is 5 times x to the fourth plus 3x squared. So what's the domain of this function? Is it also all real numbers? Well, even though this is more complicated, you can still put any number that you want in place of x. Like 3, you could put 3 in place of both of these x's, square it, multiply by 3, raise it to the fourth, and add 5, add those numbers together. Again, nothing goes wrong, so we still have the same domain, everything. I'll just use the interval notation this time. So for both of these functions, I'm looking at them, nothing goes wrong for any number that you choose, and that's why the domain is all real numbers. Here with this last function, h of x, 2 divided by x minus 4, same question, what is the domain of this function? Now I see I have a fraction. Am I allowed to put any number that I want in place of x, or will something go wrong here? The thing to note is that anytime that you divide by 0, well, that's not allowed. You'd get an error message if you tried this in a calculator. And I see a fraction, so it's already making me think, okay, if there's a number that when you put it in place of x, you divide by 0, that number would not be in the domain of the function. You'd have to throw it away. So if you're looking for this number, I think it's simple to find, but you're asking, well, when is the denominator equal to 0? And if you were to add 4 to both sides of your equation, you can see, well, that number is 4. If you try to put 4 in this function, here's what happens. So you take the number 4, you plug it into the function, you simplify the expression, and, oh, well, that's 2 divided by 0, and that is not a number. This does not work. So that number is not allowed in the domain. Now, every other number is okay, though. Any other number that you choose, anything besides 4, you don't divide by 0, and you would get a number back, so all of those numbers do work. If you want to express this using interval notation, you can say, I can use everything from negative infinity up to and not including 4. I skip over 4 and I say everything from 4 to infinity. And we can use this union symbol to say, well, the answer is both intervals, this one and this one. A quicker way to write this would be to say something like, oh, well, the domain is every x value except 4. So if you use an interval, you'd have to write it like this, using this union symbol because you have two pieces. But here's like a really fast way to write the same thing. So in example 2, same question. I'm given this function, f of x. I want to find the natural domain of the function. Those are all the numbers that you are allowed to put in place of x, meaning you'll get a number back. So here I see a fraction, and again, it's making me think, well, I know I'm not allowed to divide by 0. So maybe what I should do is take the denominator, set it equal to 0, and see if there's any numbers that make this a true statement. Whatever I find, I don't want to include in my domain. So where is this equal to 0? I think that I can factor this. So that's an x and an x. Both have to be negative. So two numbers that multiply to 12 yet add to negative 7 are going to be 3 and 4. So this is how you can factor this expression. But once I know this, I will set each factor equal to 0 and solve for x. Well, in the first one, that's going to be x is equal to 3. And the second, we get that x is equal to 4. These two numbers, if put into the function, make the denominator equal 0. And those are the only two numbers where that happens. What this means is we are not allowed to use 3 or 4 for the domain of this function. So if you're being very quick about it, you could say, well, x can be anything except 3 and 4. Let's also express our answer as an interval. What would that look like? I'm actually going to draw a number line first, just to think about the numbers that do work. So here's 3 and 4, and what we're saying is, okay, I don't want to use 3, I don't want to use 4, but I want to use everything else. If I want to write an interval, I'm going to have 3 separate pieces, and I'll take the union of them. I want everything that is less than and not including 3, so that interval will be from negative infinity up to and not including 3. I want everything between 3 and 4, not including 3 and 4, so I'll say, okay, everything from 3 to 4. And then, well, I also want everything that's above 4, so that is going to be 4 to infinity. I'll use a union symbol to say I'm taking all 3 of these pieces together, and that is the domain of this function. In example 3, let's find the domain of the function g of x is equal to the square root of x plus 4. When it comes to the domain, we saw with a fraction, division by 0 is a problem. When it comes to something like a square root, you can't take the square root of a negative number. Like this would give you an error. So this is not a real number. So for this square root, what we want to do is find all the numbers that are either 0 or positive underneath the square root. I think the simplest way to do this is to take the expression under the square root and ask, well, where is it greater than or equal to 0? Wherever this happens, all of these x values will be in the domain of the function. It's pretty easy to solve this inequality. You could subtract 4 from both sides, and you get that x must be greater than or equal to 4. If you put negative 4 in place of x, you get 0, and you're allowed to take the square root of 0. And anything that's greater than negative 4 will give you a positive number. So the domain here is going to be all numbers starting and including negative 4 going towards positive infinity. Anything that is smaller than negative 4 will not work in this function. Just for example, like does negative 5 work? And the answer is no. If you put this into the function, g of negative 5 is the square root of negative 5 plus 4. That's the square root of negative 1. And as we said, this is not a real number. So when it comes to finding a domain, there's really 2 things to look for. Do you have a square root? If so, you don't want anything to be negative underneath the square root. Or do you have a fraction? If you do not want to divide by 0. Let's move on to the second topic of this lesson. The composition of f of x with g of x is the new function. We would read f composed with g of x, and this is how you compute it. Any place that you see an x, you replace it with g of x. Let's try that with the 2 functions in example 4. Here we have f of x is equal to 3x plus 2, and g of x is equal to 1 minus x. So if we want to find f composed with g of x, the formula over here says take your function f, and wherever you see an x, you're going to replace it with a g of x. So how does that work here? Okay, well, I'm looking at the function f, and I see there's an x right here, and that's the only x in the equation. What we will do is take the function g and substitute it and put it in place of this x. That means we get the following. Here's my function f. It's 3 times x plus 2, but in place of that x, I'm putting 1 minus x, which is g. And that's it. This is f composed with g of x. We can simplify this a little bit. If we distribute the 3, we get 3 minus 3x plus 2. Maybe we'll combine some like terms and write this as minus 3x plus 5. So this is the composition that we're looking for. I put this other question here. What is the domain of this composition? If you look down here at the formula that we end up with, it's a line, and we're allowed to put anything that we want in place of x. So from this formula, I can see that the domain is all real numbers. Basically, I don't see a fraction, I don't see a square root. Nothing's going to go wrong with any number that we put in place of x. We also have to consider the original functions themselves. The domain of f and g, well, they're both all real numbers too. So there's no number that will cause a problem with this function. And for example 5, here we have two functions f of x and g of x. I want to find f composed with g as well as g composed with f. See if there's a difference between these two. And then at the end, we'll ask, well, what's the domain of these functions? I think it's worth noting at the very beginning, what's the domain of f of x? I see there's a fraction, and I know if I put -7 in place of x, that will create division by 0. That is the only number you can't use. I'm just going to make a little note of this to myself. In the function f, you are not allowed to put -7. That's no good. Now for the function g, okay, it's x minus 12. Nothing goes wrong. There's no fraction. There's no square root. So I'll just make another note. Okay, well, the domain here is going to be all real numbers. Everything works. That being said, let's start by finding f composed with g of x. So f composed with g is saying take the function f, and wherever you see an x, put a g of x. Well, the function f is 5 over x plus 7, but instead of x, we were plugging in x minus 12. Okay, we can simplify this thing. Let's see, that's 5 over, well, I don't really need the parentheses. And I can combine the -12 and the +7 to -5. So here's a simplified version of the formula for f composed with g of x. It is 5 over x minus 5. And just by looking at this formula, I see there is one number that I'm not allowed to use. I cannot put 5 in place of x of this function. If you do, you would create division by 0. So not only do we have the formula for the function, but I know the domain is everything from -infinity up to and not including 5, and then everything from 5 to infinity. You could also simply just say, well, x can't be 5, but both of these are a fine way of expressing the answer. Now, what about the function g composed with f of x? So this is different. This says you have the function g, but in place of x, you're now going to plug in the function f. So what this looks like is, okay, we take the function g of x, which is x minus 12. It's x minus 12. But instead of x, we're plugging in f, which is 5 over x plus 7. Here, again, we don't really need the parentheses. This is just 5 over x plus 7 minus 12. And really, that's a fine formula for g composed with f. Notice that this formula is different than this formula. It's worth noting that, in general, f composed with g of x is not the same thing as g composed with f of x. Typically, they're different. But the real question is, all right, well, we have the formula. What is the domain of this function? And I can see -7 is not allowed. So you could either say, well, x is not equal to -7, or you can take everything from from negative infinity to -7, all the way from -7 to positive infinity. So basically skip over -7 and everything else works. One final thought is, right at the get-go, I knew -7 was not going to work in this composition. And the reason is, you first have to put numbers in place of f before they get put into g. And since you can't put -7 into this function, I knew it was never going to work, but it was actually also reflected in the formula too. So that is everything for this example.